Sample problem 9.2. Acetic acid, the substance that gives vinegar its characteristic smell and sour taste, is sometimes used in combination with corticosteroids to treat certain types of ear infections. Its Lewis structure is given. Determine the molecular geometry about each of the central atoms and determine the approximate value of each bond angle in the molecule. What, if any, bond angles would you expect to be smaller than the ideal values? Okay. All right, so let's redraw the Lewis structure here. So in this particular problem, we're not going to draw the three-dimensional arrangement of atoms. We're just going to draw the Lewis structure and then predict what type of bonding angles we would expect for the molecule. Okay, there we go. All right, so here's how we'll do it. We'll identify central atoms. So I'm going to call this the carbon 1. That's the first central atom, meaning it has atoms that it's bonded to. So here's what you do for that atom. So I'm going to call it C1. You count up the number of surrounding atoms, any atom that's bonded to that carbon. So this hydrogen, well, let's not use dots because we might confuse those with Lewis dots. So we've got the hydrogen, a second hydrogen, a third hydrogen, but there's also a bond to the other carbon, to the second carbon. So that's 4. So really, it's AB4, right? No lone pairs on that first carbon. AB4, oops, my spelling is off here. Tetrahedral. And the angle for tetrahedral is 109.5 degrees. So we would expect the angles between these atoms all to be 109.5 degrees. Carbon doesn't have any lone pairs on it, so there's very little deviation from that. It should be relatively close to 109.5. Now let's try the second carbon atom, so C2. Now, for that one, it's different. It's bonded to the first carbon, but it's doubly bonded to oxygen, and then it's bonded to the oxygen here. So that's really AB3. No lone pairs. That would be called trigonal planar. And trigonal planar is 120 degrees. Okay? And let's take a look at the oxygen. I'll call that atom number 3. The oxygen is bonded to a hydrogen, and it's bonded to a carbon. So that's AB2, except that there's also 2 lone pairs. Okay, that's called bent. And bent is approximately 104.5 degrees, right? Now, because the carbon is doubly bonded to an oxygen, carbon 2 is doubly bonded to oxygen, the bonding that takes place here, that extra bond, takes up a little more space. So it will have a tendency to push the other bonds a little bit closer together. So it's a little bit under 120 degrees, but it should be relatively close to that. The other angles should be pretty close to 1. Well, bent is 104.5 for the oxygen. This carbon 1 over here, there aren't any lone pairs, no double bonds or anything like that. It's all single bonds, so it should be pretty close to 109.5. Okay?